On the last question, we've also got a histogram, no table given with this one, and we have to calculate an estimate for the mean weight of these boxes. Okay, now this one's a bit more tricky. We're going to have to draw in our table first, so if we start with that. Okay, it's going to be quite a large table. Okay, right, well, one thing we can definitely spot straight away is the class width. Now this is about weight of boxes, so we'll call this weight, and if we give it the letter W, then that means we can refer to it in here by using this continuous data notation, using this inequality notation. So W greater than 0 but less than 5 is our first group. Okay, the next group is when it is greater than 5, the weight that is, but less than 15. Okay, then we've got a row, a bar which is greater than 15 but less than 21. Be careful reading off your axis. And then greater than 21, less than 25. And then the final one is greater than 25, but less than 35. Okay, and I'm just going to add in some horizontal lines just because that looks terrible. Okay, not the neatest in the world, but it'll do. Right, we now also need to work out the frequency. Now to do that we need to know the frequency density, which fortunately has been given to us. So their first frequency density is 0.8. The second bar's frequency density is 2.4. Just watch your scale, make sure you find out what it's going up by. The third one is on 2. Fourth one is all the way up to 4, and the last one is 0.6. Okay, now to work out the frequency, we times the frequency density by the class width. So 0.8 times 5 gives us 4. There's 4 boxes represented in this bar there. 2.4 times 10 gives us a frequency of 24. So we should notice that this is 6 times as big as that. Okay, 2 times 6 we've got here is the class width, so that gives us a frequency of 12. We've got 4 times 4 here, so that's a frequency of 16. And in the last one we've got 0.6 times 10, which gives us a frequency of 6. Okay, now if you remember, we've worked out means and averages from tables like this in the past. Ignore the frequency density column. We've done it when we've got groups and we've got frequencies, and it is an estimate for the mean because we don't know how much each of these boxes weighs exactly. They could all weigh 5, they could all weigh very close to 0. So we're going to have to go for the midpoint and just hope that that's a good estimate for those few boxes. And in this column we're going to do the midpoint times the frequency. Okay, so the midpoint of that group, 2.5. Midpoint of the next one is 10. Midpoint of this, remember if you want to find out the midpoint, a good way to do it is to add them together and divide by 2. So that'd be 36 divided by 2, which is 18. Midpoint here is 46 divided by 2, so 23. And the midpoint of this one is 30. Okay, so 2.5 times 4 is 10. 24 times 10 is 240. 12 times 18 is 216. 16 times 23. Oh, I'm going to have to get a cat. No, I can do this without. Okay, so 16 times 20 is 320. 16 times 3 is 48. So that's 368. And finally, 6 times 30 is 180. Okay, now we need to work out the total of this column and divide by the total of the frequency. Well, I can find the total of that first. So we've got 28, 40, 56, 62. And the total of this column, I'm going to cheat because I worked it out earlier, it's 1014 I believe. So the mean is 1014 divided by 62. I can't remember that one off the top of my head. 16.4, and rounding it to one decimal place is accurate enough for us. So I'll just put in brackets that I've rounded that. And that's the answer.